roots, we're talking about the positive, or it could be negative. And most of the time, we're looking for a positive or the principal square root, but you need to know that it could be a plus or minus. Later on, and some of you may have worked with the quadratic formula. Anybody know what I'm talking about, the quadratic formula? Okay, well, we will be looking for something, and we will use that symbol because we will say we're looking for the positive or the negative value. Okay, so there are times when you want both. Most times we want the positive square root. Okay, now this happens just to be one of my own bugaboos. So we know that the square root of 4 is 2. What is the square root of 2?
2 or
1?
1 point.
1 point what, somebody? What? No calculators. No calculators. How would you figure it out? Stephen? No calculator. A lot of guess and check. What would you guess to start with? 1.5. 1.5? Okay, so we know that it might be 1.5, and that's a good guess because I did that work for you. 1.5 times 1.5, and the answer is what?
1.2.
Is too big? So then if this is too big, using 1.5, what should I do?
Lower.
Okay, give me a number.
1.3.
Okay, well, I did actually 1.4, and when I got 1.4, it was what?
1.42.
Okay, 1.4 is too small, so again, it would be a guess and check. Now, remember, have a little pity for me, I grew up before there were calculators. Okay, so it wasn't just, oh, whip out the calculator and plug it in. So when I was in 9th grade, we did guess and check. All right, and pardon me? When I was a graduate student in 1974, and in 1974 I bought my first calculator and paid. It was very simple. It was not a graphing calculator, could do none of the stuff that your calculators can do. The most complicated thing that it could do, I believe, was that it had the trig functions of sine, cosine, etc. And I paid $100 for it then.
Wow.
Yeah, so a cheap little calculator that you guys probably get, it was, you know, $5, and at that point, so what did mathematicians use? They used a slide rule, or they used tables, and we'll talk about the tables that were passed on from generation to generation of all the work that was done. Okay, so I just want to show you, I want to move on. This is just a slight aside. Michael, you're going to move, okay, if I have to ask you to stop talking again. Okay, so at this point, I'm just doing a lot of guessing and checking. I did 1.42, and again, 1.42 was too big, and I went with 1.41, and 1.41 is not quite big enough, and when I do punch it into a calculator, you can see to get as precise as possible, it's going to go out several digits. And what kind of a number do you think it would be? Irrational, okay? And an irrational number is when the digits don't repeat. Okay, so in this case I have 4, 1, 4, 2, 1, 3, 5, dot, 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 it continues. Okay, your calculator only has room for, I don't know, maybe 8 numbers across, so that's about the extent of what you would get. So I would like you to commit these two numbers to memory. So just like everybody knows, now I'm not asking you to memorize all the way out. You should be able to say that the square root of 2 is about 1.4, and the square root of 3 is 1.7. And those are just handy little references to have, just to have. Okay, because we know what pi is. We're going to learn about e. You might as well know what the square root of 2 is as we're going along. Okay? So so that's just, and so do you think if I said to you at some point, and maybe we'll have this on a quiz in January, if I said to you, well, what is the square root of 5, could you figure it out? So I know that the square root, and an approximation, I'm not gonna ask you to go out hundreds and thousands of places, but you could say it's about, and it's a matter of guess and check. So is it gonna be more than 2? Because the square root of 4 is 2, and the square root of 9 is 3, so 5, it would make sense, is going to be some number between 2 and 3. Okay, good. All right, a little historical context. Let me see. Just want to make sure I have this in the sequence. All right, so on Friday, we had started with this problem, okay? And this is what I would really like you to write the remember stuff, because that's what you need to remember, okay? So if I gave you this problem, and this was problem number 5 in the textbook, what is it that we remember, that we need to remember? We need to remember that we can add or subtract only with the same radicand. And the radicand is the number underneath the radical symbol. Okay, so you have to have the same radicand, and it's kind of like fractions. So if you know I can only add fractions with a common denominator, I can only add variables that are the same, and I can only add if the radicands are the same. And like fractions, can I rename fractions? 1/2 is equal to 2/4 or 3/6 or whatever. I can rename my radicands if possible, and that's what I did with 12 over here. So I renamed 12 to be 4 times 3, and I just copied the problem over. And I can't do anything with the rad 7 or the rad 3. And what can I do with that 4? Okay, I know that the square root of 4 is 2, so I can take the 2 out. And you just need to remember, this is asking a question. And when possible, you answer it. So, you know, I try to make you think this is a symbol, and so is that. And for those of you who study Spanish, you know that symbol. And it's a symbol that's talking about what 2 numbers multiplied together will give me that. And so you answer the question. And you answer the question, and once you've answered the question, that number no longer is under the radical symbol. Okay? All right, so what did we say that the square root of 3 was?
1.7.
1.7. So what is the value of this number? This says 6 times 1.7. So that's what we're talking about. These numbers have values. And it's oftentimes a lot more convenient and more precise to leave it as a radical number than 1.7, whatever it was, which is an irrational number. And if we were doing a lot of multiplication, we would compound our error. So leaving it in a radical number is often more, is preferable. Okay, any questions about that?
So now can you combine the 2 that have?
Okay, so then I would combine like terms, and I could say 2 rad 3 plus 6 rad 3 is what? 8 rad 3, and I can't do anything with the 5 rad 7, so I just leave my answer. Okay? Is that pretty straightforward? Everybody okay with that? Okay, and this hopefully you had practice with an Algebra 1. It's definitely an Algebra 1 type of skill. Okay, so let's look at this next problem. Okay, and again in this one, the name of the game really is simplify, simplify, simplify. No different than if you had fractions. So my goal is to simplify, and can I rename 75? Okay, 75 is 25 times 3. Okay, and you need to remember, and this time I have a numerical coefficient here. It happens to be a -2. So when this 5 comes out, what happens to that 2 and then the 5? Yes, it's a multiplication process. Because remember, this is saying 2 times whatever this number is. And if I answer the question, the square root of 25 is 5, that's coming out, but it's -2 times that 5. Okay? So the 5 is going to come out, and that -2 is there, and then I ask myself, well, what is the square root of n squared? N. So the n comes out. So everything that comes out gets simplified, and I have a -10 n times rad 3. Now, sometimes we are looking for the principal square root, which is the positive one. So I would use the absolute value symbol, because I know that anything that comes out of the absolute value symbol is what?
Positive.
Positive. That's right. We don't always do that, but sometimes it's obvious and we just take the variable out. But if it's not obvious, we use the absolute value symbol.
Hi,
Hi.
somebody's here to pick Bradley up.
Guess I gotta go.
Okay. We're taping.
All right.
Okay? All right. So any questions on that? Are we good with that?
Wait,
I'm not moving it.
so why do you need the absolute value?
Because it is this, we're just making sure, because it's a variable, we're just
okay.
saying we want the positive value of that variable. Okay?
Do you always have to do that?
Again, and I'll give you an example below. Okay, actually I wrote it out for you. We don't always use the absolute value of the square root expression has a restricted domain. For instance, if we knew that x was going to be greater than 0, then 6, the absolute value of x times rad 2, and 6x rad 2 have equal value, because we have expressed that x is going to be greater than or equal to 0.
So will you show me that one,
How I did what? Which one?
the one that we're looking at,
This?
the multiply one?
I haven't done the problem yet.